Section number 10 is entitled Power Series. Power series, or a series, is just a it's just a polynomial that doesn't end. It's a polynomial that doesn't end, or a series that doesn't end. Actually, it's a series that goes on forever and ever. And you want to find the radius of convergence. Suppose I tell you the summation as n goes from 1 to infinity of, say, negative 1 to the n, x to the n over n plus 1. Where does this converge? Now, normally in the past, we were given something like, I don't know, summation n goes from 1 to n of 3 to the n over n plus 1. That is, this was determined, the value of this was determined by n. But right now, it's not determined just by n. It's determined by n and x. That is, you don't know what one of those terms equal unless you know what x and n are. What does this equal when n is 1? I don't know, because I don't know what n is. Excuse me, I don't know what x is. But I do know that the ratio test is going to tell me where it converges. Take the limit as n goes to infinity of the absolute value of a sub n in the bottom. That is, this just gets canceled off. You get x to the n over n plus 1. The absolute value of that. That's a sub n. The absolute value of a n. Now on the top you put the n plus 1 term. Instead of n you write n plus 1. Instead of n you write n plus 1. But if there's also another plus 1 because somebody wanted to write that, that doesn't mean you just write n plus 1. You write n plus 1 plus 1, which is n plus 2. Let's clean this up a little bit. First thing is the absolute value, the division of absolute values is the absolute value of the division. That is, we can put everything under one absolute value. Now, the numerator can stay the same. We need a little bit more space. The numerator can stay the same, x to the n plus 1 over n plus 2, but the denominator gets flipped over. So let me write n plus 2. It becomes n plus 1 over x to the n. Now, let's clean this up a little bit. X to the n goes into x to the n plus 1, x times. So we have x times n plus 1 over n plus 2. Well, this limit is x because this fraction gets closer and closer to 1. If n is a billion, if somebody owed you $1 billion plus $2 and they cheated you, they gave you $1 billion plus $1. However sneaky feeling, you're not going to say a word. You're going to take that money and you're going to run. You're going to go, I'm a billionaire, I'm a billionaire. You're not going to go, I'm a billionaire and $1. Or that person cheated me out of $1. Those numbers are so close. $1 billion plus 1, $1 billion plus 2 are so close that when you divide them, you get close to 1. Times x is x. Now, the ratio test says it will converge when that limit is less than 1. It will converge there. That is, it will converge between negative 1 and 1. The radius of convergence is the distance from the center to one of the endpoints. It's halfway. This distance is 2 divided by 2, you get 1. It's from the center of negative 1, 1. From 0 to 1 is 1. Just find the distance from the end, between the endpoints, that is, subtract them. This number minus that number. 1 minus that number is 2. Divided by 2, and you have the radius of convergence. If x is less than 1 in absolute value, if x is between plus and minus 1, then this mess on top will converge. The radius of convergence is 1. I always wondered why they cared about that. I'd rather know what the values it converges for are than to know the radius of convergence. So rather you tell me it converges from 7 to 1,000,000 than to tell me that that's almost 500,000. The radius of convergence is 500,000. I want to know what 500,000. Let's say from 0 to 1,000,000 it converges. So the radius of convergence would be half of the distance between it. Be 500,000. But that doesn't say much. At least I don't see why it does. Suppose you wanted to find the radius of convergence of this. This is code for apply the ratio test. You want the limit that then goes to infinity. In the bottom, you put the absolute value of this. That is, you put 2n factorial x to the n over n factorial. On top, instead of n, you put n plus 1. So it's 2 times n. Now it's 2 times n plus 1. The whole thing factorial, x to the n plus 1 over n factorial. And you flip over the denominator. You multiply instead. So you have 2 times n plus 1 factorial, x to the n plus 1, n factorial, and something did go wrong in the bottom. It should be n plus 1 factorial. N plus 1 factorial, n factorial, 2n factorial, x to the n. Okay, the first thing I would say is x to the n goes in here exactly x times. And n factorial goes in here n plus 1 times. Remember, n plus 1 factorial is n plus 1 and then n times n minus 1 times n minus 2 down to 1. But the thing is what's in those brackets, that's n factorial. N factorial is n times n minus 1 down to 1. This cancels out to 1, and you get n plus 1 in the bottom, which is just what I put. I put n plus 1 in the bottom. Okay, now for the 2n and the 2n plus 1. Two times n plus 1, that happens to be 2n plus 2. And if we're taking the factorial of it, let so be. So it's this number, 2n plus 2, times 1 less, 2n plus 1, times 1 less, all the way down. But the 1 less is 2n, all the way down to 321 is 2n factorial. And if you have 2n factorial in the bottom, 2n factorial in the bottom, that cancels out, and you get that survived. That is, you get 2n plus 2 times 2n plus 1. So what you get is the limit as n goes to infinity. If you actually multiply this out, you'll get 4n squared plus 2n plus 4 more n, that's 6n plus 2 times x divided by n plus 1. This is infinity, because the degree of the numerator is bigger than the degree of the denominator. It goes to infinity. And when you multiply it by x, x is like a constant. In fact, the x, the absolute value of x, can come in front. It has nothing to do with n. So you get the absolute value of x times infinity, which is infinity. Okay, that means this diverges, that's the symbol for all x. That is, the radius of convergence, I guess, is 0. There is no radius of there is no values where it converges. Suppose you have the summation of x over L to the n, and n goes from 1 to infinity. I mean, you can jump on this immediately. You can say this is like a geometric series. N goes from 1 to infinity of r to the n. It converges if the absolute value of that is less than 1. It converges if this absolute value is less than 1. That means x over L is in between -1 and 1. Multiply both sides by L. We'll assume L is positive. We'll assume that L is positive. Okay, so we get that. Excuse me, we get that. The distance is 2L. So the radius of convergence is L. Now, even if L were negative, it would still be the same result. This is if L were positive, from here down. Now, if L is negative, when you multiply both sides by a negative number, and you multiply all three sides by L, you'll get that. But since L is negative, it becomes that. Remember? Okay, I meant to put x in the middle. Remember, the left side is L, which is a negative number. He's claiming L is less than 0. And if L is negative, and you put a minus in front of it, it becomes positive. So even on this side, the distance is 2L. The distance is actually negative L. The radius shouldn't be a negative number. And you can just say the radius of convergence is the absolute value of L. So in the end, remember, it's either this if L is positive, or it's that if L is negative. So you just say the radius of convergence is the absolute value of L. Now, for the fun of it, let's see what would happen if we use the ratio test. Let's see what happens if we use the ratio test. We take the limit of a sub n in the bottom and a sub n plus 1 on top. This goes in here, x over L times. This is equal to the limit of x over L. Interesting. Okay, as n goes to infinity. There's actually no n's left. So what you get is x over L. But for this to converge, this limit must be less than 1. But that's what I said when I thought of geometric series. I'm saying that this piece here must be less than 1. It's exactly what I have. So you could have done it that way as well. Okay, suppose they want us to find the interval of convergence. That's 3x to the n divided by 2n factorial. So we look at the limit. We look at the limit as n goes to infinity of just this in the bottom. And the same thing, but with n replaced with n plus 1. Now if you want to invert from the beginning, because you see it happening, you could just write down what I'm writing down here. That is, you can start with that. You can write down the n plus 1 term and then multiply that by the reciprocal of the an term. This goes in here 3x times. And we talked about how this goes in here 2n plus 2 times 2n plus 1 times. But that's 0. That's 0. The denominator has an n squared term. If you FOIL it out, like we did earlier, you get an n squared term. The top, n to the 0, which is 1. 3x times 1 is 3x. Goes to 0. That means the radius, the interval of convergence is everything. It's always less than 1. I shouldn't have said it equals 0 implies that interval. The fact that the limit is less than 1 implies it's from negative infinity to infinity. And you never ever include infinities and negative infinities, which means you don't have to check the endpoints. What would it mean to converge at infinity? There is no number infinity. Suppose you have x to the n over n factorial. What's the interval of convergence from 0 to infinity? Well, you can put the n plus first term down, n plus 1 factorial, and then take the reciprocal of the an term. This goes in here x times. And n factorial goes in there n plus 1 times. So you have the limit of the absolute value of x over n plus 1, but that's 0. That's 0, which is less than 1 always. So the interval of convergence will be that. Let us find us another nice problem. Okay, let's try this one here. Suppose you have the summation that then goes from 0 to infinity of -1 to the n plus 1 times, say, -1 to the n plus 1, and this is all being divided by what else but n plus 1. Okay. So now, since the ratio test, when you do the limit, its absolute value, you can really ignore that, because this is just plus or minus 1, and when you take absolute value, it's just 1. So in the bottom, well, actually, we're going to flip it over right away. So in the numerator, instead of n, we put n plus 1. So we get n plus 1 for n plus another 1, n plus 2. Same for the bottom. Then we flip over the n term, the base of n term, for the absolute value of it. N plus 2, excuse me. So we get this over, we get this. And what happens is this goes into x minus 1 to the n plus 2 n plus 2 power x minus 1 times. Now remember, in case this is bothering you, the absolute value of a product, the absolute value of AB is the same as the absolute value of A times the absolute value of B. And of course, if you have x over y times z, this is the same as x times z over y. After all, when you multiply the tops, you get xz, and the bottoms are y. So this is the absolute value of x minus 1 times the absolute value of n plus 1 over n plus 2. And absolute values are very, very friendly. Excuse me. Limits are very, very friendly. If you have a sum, you can take the limit of the terms and then add them up. If you have a difference or a product, you can distribute. That is, the limit of this doesn't care about n. Doesn't care that n is going to infinity. It's just x minus 1. And the limit of this is 1. Whenever the degrees are the same, divide the numbers in front. In our case, they're understood to be 1s. 1 over 1 is 1. So we get this, and this is less than, we want that to be less than 1. So we get x minus 1 is in between -1 and 1. Add 1 to both sides, excuse me, to all three sides, and we conclude that x is in between 0 and 2. So what we know now is 0 to 2. It converges between. What about at 0? What about at 2? So we need to investigate that. We need to go back to the original problem and plug in 0 for x. 0 minus 1 is minus 1. So we have the summation of negative 1 to the n plus 1. We got that from right there. And now we have the same thing again. Negative 1 to the n plus 1 over n plus 1. And n goes from 0 to infinity. Okay, let me erase most of this. I'm really looking at finishing up the very, very last line on the board. I want to know whether or not I should say equals here. Now, without thinking too much, you should know that the signs here are going to alternate. Now, what I meant by when I said you don't have to think too much, I don't care if it starts off with positive and then negative and then positive, or if it starts off with negative and then turns positive. The signs are going to alternate. And here they're going to alternate. But since they're exactly the same, they're going to alternate the same way. That is, when this is negative, that'll be negative. Negative times negative is positive. When this one's positive, that one's positive 1. Positive 1 times positive 1 is positive 1. It's always going to be 1 on the top. Now this is the harmonic series. Maybe we missed the first term, but actually we're not. When you plug in 0, 0 plus 1 is 1. Now n is 1. 1 plus 1 is 2. Now n is 2. 2 plus 1 is 3. That's the harmonic series. I know one thing about the harmonic series. It converges. It diverges. So I now know the answer to my question at 0. I will not allow x to be 0. I will not allow x to be 0. Okay? Can it equal 2? Can x be allowed to equal the number 2? That is the new question. Can x be 2? So I come back over here, I erase the work I did for x equaling 0. Now I let x equal 2. So let me rewrite the problem because I wrote on it a lot. 2 minus 1 is 1. 1 to any power is 1. It's 1. This mess, when x is 2, is 1. And this times 1 is just that. This here is the alternating harmonic series. It alternates. That converges. That one converges. The alternating series, the alternating harmonic converges. The harmonic diverges. So there's the answer. From 0 to 2, do not include 0. That's an open bracket. Do include 2. Close bracket. Next problem, they give us one power series, and they asked us to find the interval of convergence for a number of things. F of x, F prime of x, double prime of x, and the integral of f of x dx. Okay, and they tell us, say for the first one we'll look at is we have x over 2 to the n. N goes from 0 to infinity. Well, this is a geometric series where that's r. We want r, the absolute value of r, to be less than 1. That is, we want x over 2 to be in between negative 1 and 1. You need to be able to go from here to the next line. The absolute value of k is less than a, and a is positive. Then k is in between negative a and positive a. And why is that reasonable? Here's 0, here's a, here's negative a. The absolute value of all of those numbers I just highlighted are less than a. But the absolute value of these numbers are the same as the absolute value of those numbers. Anything in between here, if I ignore their sign, I will end up in here. And those numbers are less than a. Absolute value of k means ignore the sign of k. K, this is a symbol for k is in between. Just like that's the symbol for addition, this is the symbol for subtraction. I mean, you're older now, you're more mature. Accept a new definition or new symbol. That's the symbol for k is in between. And you might say, k is in between. K is in between what? This number and that number. 3 and 7. This tells me, when I read this, I say k is in between 3 and 7. Okay, so now to finish up our problem on the left, we multiply both sides by 2, and we'll be done. Excuse me, multiply all sides by 2. Negative 2x and 2. The problem says find the interval of convergence. So we know it converges between negative 2 and 2. The question is, does it converge at the endpoints? What if x is negative 2? We get negative 2 over 2 to the nth power. But negative 2 over 2 is negative 1 to the nth power. And n goes from 0 to infinity. So 1 minus 1 plus 1 minus 1. This diverges. Now if n is 2, if x is 2, instead of x I say 2. X over 2, or I write 2. But 2 over 2 is 1. 1 to the n. 1 plus 1 plus 1 forever. This diverges. So, my answer is on the board. I don't have to modify it. I don't have to modify it. There it is. Negative 2 to 2. There's my answer. Now, let's look at the derivative. Would the derivative converge? And if so, where? Does it converge at the endpoints? You have to check the endpoints. Well, the derivative of this, the summation of the derivative. Bring down the power, make the new power 1 less, take the derivative of what's inside. Remember, x over 2 is a half times x. So the derivative will be 1/2, which I'll put in front. 1 over 2. So the question is, does this converge or diverge? And if it converges, where? So we'll use the limit. We use a ratio test. The n plus first term goes on the top. N plus 1 minus 1 is just n. You multiply by the reciprocal of this. That is, you get 2 over n times 2 over x to the n minus 1. Or possibly, in this case, it'd be better to divide, to actually divide. This is over n over 2 times x over 2 to the n minus 1. Since this power is 1 more than this power, we'll just have x over 2 left over. So it's the limit. Now I'll take reciprocals. At the top you have n plus 1 times x divided by 2 times 2. 2 times 2 is 4. Divided by n over 2. Well, I'll multiply by the reciprocal. And 2 goes into 4 2 times. So we have the limit as n goes to infinity of n plus 1 times x divided by 2n. Absolute value. You can factor out the constant, say x over 2, has nothing to do with n. Remember, it's in absolute values. Then you have the limit as n goes to infinity of n to the 1 plus 1 over n to the 1. Since the powers are the same, just divide the numbers in front. 1 over 1 is the absolute value of 1, which is 1. Oops. Times x over 2 in front. Don't forget the x over 2 in front. This x over 2. This limit is 1. So we just get x over 2. But we want that to be less than 1. If I'm not mistaken, that's exactly what happened in the first case. Although we have to check the endpoints. So this here tells me that x is in between negative 2 and 2. We just did that. Okay, now we have to check the endpoints. Okay, let us do that. Let us plug in 2 for x. So we get n over 2 times 2. 2 over 2, which is 1, to the n minus 1. But 2 over 2 is 1. This is just 1. And 1 to any power is 1. So we have n over 2 times this, which is 1. But n over 2 times 1 is n over 2. And this is just going to take off. You get, everything's over 2. You get 0 over 2, plus 1 over 2, plus 2 over 2, plus 3 over 2, and so on. The numerator is taking off, and then you divide it by 2. This is infinity, so it diverges. So I would not put an equal sign by the 2 on the bottom. Let us look at negative 2. Summation of n over 2 times, well, negative 2 over 2 is negative 1 to the n minus 1. So the signs are going to alternate. In fact, it's going to start off with negative, but that doesn't matter. Well, negative 0 over 2 plus 1 over 2 minus 2 over 2 plus 3 over 2 minus 4 over 2 plus 5 over 2. Well, remember, a necessary condition for an alternating series to converge is that the absolute value goes to 0. The problem is that limit of n goes to infinity of the absolute value of this, which is n over 2, this doesn't go to infinity. That implies it diverges. So it turns out, just like the first case, it doesn't converge at the endpoints. And we can take the derivative yet again. We can take the derivative again. And then we'll integrate. And if I'm not mistaken, there's absolutely no reason why we'll get the same answers for all of these. If we do, there's a word for it. It's called coincidence. What is the derivative with respect to x of n over 2 times x over 2 to the n minus 1? What's the derivative of that? Well, n over 2 is just a constant. We take the derivative of that. I bring down the power. I keep the x over 2 the same. Make the new power 1 less. And then I take the derivative of x over 2, which is a half. 2 times 2 is 4. So I'll get this n times n minus 1 over 4 times the x over 2 to the n minus 1. That is the second derivative. We call the original one f of x, and f double prime of x is the summation of this. N times n minus 1 over 4 times x over 2 to the n minus 1. Okay, we want to find the interval of convergence of this. I would use the ratio test. The limit as n goes to infinity, n plus first term. N becomes n plus 1. N minus 1, well, n became 1 more. N plus 1 minus 1 is n. Over 4 times x over 2. N is n plus 1. Minus 1 is n. And we multiply by the reciprocal. 4 over n times n minus 1 times 2 over x to the n minus 1. Well, you know what? Some of their things can get multiplied. But I still want to divide by the n over 2. I don't want to multiply by the reciprocal of the x over 2 to the n minus 1. Okay, with respect to the x over 2's, the numerator on the top is 1 more. That is, we'll be left with 1 x over 2. The 4's cancel, the n's cancel. So we're left with n plus 1 over n minus 1, n plus 1 over n minus 1, n minus 1, excuse me, n minus 1 times the x over 2. Well, this fraction goes to 1 times the constant, the x over 2. That's the answer. Okay? The x over 2 is less than 1. That means x is in between negative 2 and 2. Reverse the tape. And you'll see how I went from here to there. Now we need to check the first and we have to check the endpoints. We need to check the endpoints. Now, if you think about it, if you plug in negative 2, this piece right here will be negative 1 to the n minus 1. The signs are going to alternate. But the numerators are getting bigger. That's just the alternating part. So it will diverge if this doesn't go to 0. And it doesn't. It then gets bigger and bigger. N times n minus 1 takes off. Divided by 4, it takes off. So negative 2 doesn't work. What about plus 2? You'll have 2 over 2, which is 1 to the n minus 1. The first circle times the second circle, which is 1, is just the first circle. Multiplying by 1 doesn't do anything. That takes off. A necessary condition for convergence of a series with positive terms is the terms go to 0. It's necessary. That is, if it doesn't go to 0, it won't converge. If it does go to 0, we don't know. But it must go to 0 for it to converge. Okay, I mean, for example, if you want to convince me that you live in the United States, you can convince me that you live in Utah. If you convince me you live in Utah, that was sufficient. That was enough for me to know that you live in the United States. However, if you want to convince me that you live in Utah, but you just convinced me, you showed me that you lived in the United States, you're still in the game. I mean, if you showed me that you lived in Canada, then I know for sure you don't live in Utah. Okay? That is, it's a necessary condition for you to live in the United States if you're going to live in Utah. Okay? It's a necessary condition. If you want to convince me that you live in Brooklyn, it's enough for you to convince me that you live in New York City. Okay, Brooklyn is part of New York City. It's necessary. Okay? If you couldn't convince me, that is, if you convinced me that you didn't live in New York City, what are the chances you live in a portion of New York City? Okay. When x is 2, the terms are going to infinity. They're not going to 0. Therefore, it must diverge. And once again, the answer was x is in between negative 2 and 2, not including the endpoints. Let us go to the integral. So I integrate the terms one by one. That is, I integrate the general term. I integrate n over 2 times x over 2 to the n. Oh, excuse me. I integrate x over 2 to the n. This time, I want to integrate. Now, the thing about integral signs is they can go in front of the summation. Dx, here it's dx, of course. N goes from 0 to infinity. That's why you can go in front, because the integral signs have nothing to do with the n's. So this becomes the summation as n goes from 0 to infinity. Remember, x over 2 to the n is x to the n over 2 to the n. So in fact, you can even factor out in front of the integral sign the 1 over 2 to the n. Had nothing to do with x's. So you get the summation of 1 over 2 to the n. This integral. You add 1 to the power, and then you divide by that power. That's the integral. And then goes from 0 to infinity. I want to know if this converges or diverges. That's what I want to know. Excuse me. I want to know where it converges. Of course, you all say in between negative 2 and 2. Alright, let's see what happens. This one I think I flip over. The n plus first term will be this. Times the reciprocal of the an term, which is right there. Get 2 to the n times n plus 1 over x to the n plus 1. Well, since this power is 1 more than that power, and the bases are the same, then this goes in here x times. Same argument why that 2 to the n goes into 2 to the n minus 1 2 times. So I want the limit of this. The limit of this. The limit of the absolute value of x right there times the absolute value of n plus 1 to n plus 2. And here it looks like we get a different answer. No, we got x over 2 again. The limit of this doesn't have anything to do with n's, so it stays the same. The limit of this is 1. Take a really, really, really large number and add 1 to it, and in the bottom, take that same large number and add 2, you're going to have 1. If you take this number in a long, long, long string of zeros over 1, and then in the bottom, you have the same number of zeros, but you have a 2 in the bottom, plug that into your calculator. Tell me you don't get 1. And if you don't, because your calculator is good at approximations, it'll be very, very close to 1. Times 1, which is this, and you want this to be less than 1. That is, you want x to be in between negative 2 and 2. So now, like always, we have to go back and check the endpoints. We need to check the endpoints. What happens when n is 2? What happens when n is negative 2? When I say what happens, I'm talking about does it converge or diverge? Now, I want to rewrite it just a little bit differently. 1 times x to the n plus 1 is x to the n plus 1 over 2 to the n. I want to put that together. No, maybe you won't see to do that. Let's not do that. So we plug in 2. We plug in 2 for x. So we get the summation of 2 to the n plus 1. And I can make this division line one straight line right here. And 1 times x to the n plus 1 is x to the n plus 1 over 2 to the n plus 1. Well, the 2 to the n goes into 2 to the n plus 1 2 times. So now you have the summation of 2 over n plus 1. It then goes from 0 to infinity. This is the harmonic series where the numerator is 2. That is, you have 2 over 1 plus 2 over 2 plus 2 over 3, etc. I'll factor out the 2. You have 2 times 1 over 1 plus 1 over 2 plus 1 over 3 and so on. This diverges. It's the harmonic series. 2 times it diverges. Okay. What about negative 2? What if x were negative 2? If x were negative 2, you would have negative 2 to the n plus 1 over 2 to the n. I will break off a negative 2 in the numerator. So we have negative 2 times negative 2 to the n over 2 to the n times n plus 1. We have a rule that says if you have a to the c divided by b to the c, This is just divide the A and the B and raise that to the C power. I have the same powers there. This is a summation of negative 2 times negative 2 over 2 to the nth power over n plus 1. Okay, negative 2 over 2, of course, is negative 1. The negative 1 to the n, that's the alternating part. That is, we have an alternating series. We have the summation of negative 2 over n plus 1 times negative 1 to the n. Well, I can factor out the negative 2, and then I have the alternating harmonic series. This is the alternating harmonic, which converges. There we go. It converges. When you multiply it by negative 2, it converges. Yippee. This time we keep the negative 2. So, the integral converges for x is in between negative 2 and positive 2, including negative 2. So there's a variation. Okay, this finishes the section on power series.